Now let's talk about mechanical mates. As you can see from the images, mechanical mates are used to simulate real mechanical motions such as movement of gears, rack and pinion movement, rotation of screw, cam follower mechanism, universal joint. So mechanical mates will simply allow assemblies to behave like an actual mechanism. So under the mechanical mates, we have a cam, slot, hinge, gear, rack and pinion, screw and universal joint. So let's explore through exercises. Now in exercise, I'll give you the assembly directly. But the only thing is we have to apply the respective cam, slot and hinge and other mechanical mates. The other required standard mates are already applied in exercise file. Now the first is 9.14. Here we are going to use cam follower mate. It's very simple, easy to understand what it does. It simply connect the follower with the cam. Now there is a stringent requirement. This cam must have this kind of a curvy surface. At least it must have one arc or some circular geometric sketch. Otherwise it is not going to work. Similarly for follower, it must have at least some circular edges. So they can have a tangency relationship. Open the provided assembly. Inside the assembly folder, we have 9.14. And open this assembly. Now you can see I have already applied the required mates between various components. The only thing is left out is to provide the cam follower mate between these two components. So for that, go to the mates. Now click on mechanical mates. Inside that, choose the cam. Now here I have to select the cam path. Then for the follower at this surface. So here, moment you do that, it simply create a tangency relationship. Now let's click OK. Now moment I drag this cam, it pushes the follower to follow its outer geometry. So this is purely mechanical motions, which cannot be achieved by standard mates or any other advanced mate. That's why the mechanical mates are separately given. Now in slot mate, as name suggests, it allow component to slide along a slot. So this is our slot, while maintaining the alignment relationship. So here we have this small pin which will be aligned in this slot. So when we move the wheel, because of this relationship, this link will simply move back and forth, left and right, like a crank mechanism. Open the slot mate assembly. Now we already have applied some of the standard mates. Now let's apply slot mate. So go to mates, choose the mechanical mates, and inside that select this slot. So select this surface and this surface. That's it. And right click. Now here when I rotate this, it simply pushes the pin, green pin, to follow the motion. Now let's select this again. Now we have a constraint over here, free. If I choose center in slot, let's see what happened. The entire length is measured by SolidWorks and it keep this pin in center. Let's click OK. When I try to rotate, it is not able to rotate because we already have positioned this pin in centrally. So under this property manager of mates, select these applied mates to edit it. Again, same thing, distance along the slot from this end, it is at 45, let's say 60. Okay. So any other constraint other than free will simply lock the position. So let's go to the free. and click OK. So this will allow free movement. Again select it and click the lock rotations. Now what happened here is there is no movement because we have fixed it. So let's untick and try it again. Now it is moving. So using slot, you can add the relation between the pin and slot. Now under the hinge mate, as name suggests, it restricts the movement to rotation about a single axis. So this is our single axis about which this simply flap will rotate, just like a door hinge. Here basically it's a combination of concentric and coincident mates. With the angle mate limit, you can control the movement of these two selected parts by this value, minimum and maximum value. Now open the assembly called 9.16 hinge assembly. Now let's apply the hinge mate. Under the mechanical, select this hinge. Now let's say concentric means circular surfaces. Now coincident means I want to align this surface with this bottom surface. So we have created a simple hinge mate. Now here it rotates 360 degree, but in real life hinge cannot rotate more than 180. So we need to restrict the movement, and let's add it that hinge and add the limit. For that, go over here and click the specify angle limit. Now let's control the movement of this hinge by specifying the angle limit. Select this surface and this surface. Here the maximum angle will be 60. Or you can add any value. So here it is, minimum is 0. Let's click OK. Now let's drag this and see is it working or not. So initially it was 0. Now let's go to the 60. So it does not allow the rotation of a hinge more than 60 degree. So the movement remain between 0 to 60 degree. So using hinge mate, you can control the movement of a part about a one axis. In gear mate, we will simply link the rotation of two rotating element. In most of the cases, gear. So here rotation of two components using defined gear ratio, which will simulate the real gear motions. Now let's understand the gear ratio. Let's say how this is gear 1 and this is gear 2. Now this has 100 teeth, this has 50 teeth. So ratio is 2. 100 divided by 50 is 2. Now if B gear is driver, and if it is rotated by 1 revolution, this larger gear will rotate by only 1/2 revolutions. Or reverse, you can speak, if this smaller gear rotate by 2 times, then only it is going to complete by 1 revolution. So in SolidWorks, in the case of gear mate, we need to select this outer diameter, and that will be taken as a value for the ratio. So open the gear mate assembly. Now in this assembly, we have one gear and second gear. Now they are allowed to rotate. So let's try to position their gears in mating conditions. And then we will apply the gear mate. So try to position gear properly. Now go to mate. Under the mechanical, select the gear and now select the top surface, and similarly for this one. So it automatically pick the diameter ratio. Now these values comes from the geometry we have selected. Now let's click OK. Now let's try to rotate this. Now see, Being a smaller gear, which is our driver, it rotates the larger gear, but the ratio between them is maintained through gear mate. Now select again and look at the, let's try to reverse the rotations. So here, actually when two gear mates, they rotate oppositely, but I have click over here, the reverse the rotation, so they rotate in a same direction. Click OK over here and try again. So here see, actually teeth are penetrating each other. So to avoid such situations, let's go ahead and disable this or suppress this mate. Now position this properly. Position the gear properly. Okay, like this. Now let's unsuppress that mate. Now when I rotate it, see, they are not penetrating. So you need to take care the position of teeth and then you apply this gear mate. Now in 9.18, we're going to explore mechanical mate called rack and pinion, which convert rotating motion of a pinion into linear motion of a rack. Now only thing we have to require is to select the rack and the face of pinion. Then you have to control the value, that is rack travel per revolution, or you can choose pinion pitch diameter. So here, when we rotate this pinion, it will move the rack up and down. So let's try in SolidWorks. Open the assembly file called 9.18. Now here, rack is moving straight away up and down. Let's position properly. Now let's apply mechanical mates. Here I will choose rack and pinion mate. So choose this edge, and for pinion choose this one. So automatically it find the pinion pitch diameter. You can also choose rack travel per revolution. Let's say I want to make it 100. Now let's click OK. Now see, when I rotate this, the rack also moves. In real life, the actually pitch diameter of a pinion control the linear motion of rack. So with the help of these two settings, rack travel per revolution or pinion pitch diameter, you can control the movement of a rack. Let's say make it 40, let's say. Right, larger the value, faster the movement of rack. So using rack and pinion, you can create a motion rack and pinion between the smaller gear, which is called pinion, and straight gear, which is called rack. In screw mate, as the name suggests, it converts rotational motion into linear motion based on specific pitch. Here we can either give revolution per mm or either we can give the distance per revolutions. All we need is to select the two curved surface which define the screw and the reference part. Now open the exercise 9.19. Now let's apply screw mate. Go to mechanical and choose the screw. Here we need to select two surfaces. One is this outer surface of thread and the circular surface. Now here I can give revolution per mm. Let's say I want to increase to 2.5. So what does it mean? It means to travel 1 mm, revolution must be completed by 2.5 mm. Let's try to see in action. For 2.5 mm revolution, the 1 mm movement of spindle is observed. Now let's edit it again, and this time I will choose distance per revolution. Now I want to travel 2.5 distance per revolution. Let's click OK. So if I give you the more distance 2.5 or 5 or even more, that with the minimum rotation the screw will travel faster. So it's a relation between the pitch and rotation. So using this kind of a screw relation, you can create a screw pair motion. Now in 9.20 we are going to explore the last mechanical mate is called universal joint. It allows rotation about two perpendicular axes. It's simply simulating a universal joint. So which are two perpendicular axes? This one axis and second axis. Open the exercise 9.20. Make sure before you apply universal joint, try to position these two ends properly like this. It should be that no part is touching each other. That means no penetration of material. Now let's go and apply the universal mate. Now click on universal joint. Select these two cylindrical surfaces and right click. There are no further settings. So moment I rotate this, the opposite part also rotate. And this is what actually a real life movement of a universal joint. So using universal joint mate in mechanical mates, you can simulate the universal joint motion.